Okay.
It's time for me to head out, guys. But I think I'm gonna read the holochain paper this week. So if we don't
Oh,
have anything going on next week, we
cool.
can discuss that.
Yeah.
Holochain sounds cool AF, man. That sounds great.
Awesome.
Yeah.
All right. Well, I'll talk to you guys next week.
Yeah, I want to do Rolang on holochain.
Rolang on holochain. Yeah, you were talking about R boxes, right?
Yeah.
Yeah, and that was sort of like a holochain type of thing, or you were thinking that it could be something like that.
Yeah, it would be like the hollow box or whatever it is.
Yeah, hollow box. Yeah.
But no, I'm talking about using Rolang for process orchestration on top of the actor model on holochain.
Okay. Well, see you guys later.
Cool. See ya.
See you, Jay.
See you. Bye-bye.
All right, I'm excited, Tomislav. What do you have for us?
I found a very simple example to to express this. Is this big enough?
Yeah.
Yeah, definitely.
I don't want to show you everything. I want to make a gradual modifications.
Oh, great idea. Yeah.
So I first want to start from this like very simple. This is like a dictionary or key value.
Mm-hmm.
So, and it's very concrete, and it's a list of pairs. So a string is a key, and integer is a value.
Mm-hmm.
And this is really like an initial representation, and we can say, okay, can we do this like more abstract? So I can write this almost the same, but I can abstract the pairs. So I can say something like this. So what I did is just I removed the pair, and I replaced it with some kind of function that I will supply to this structure.
Yeah. And just takes those create arguments and turns them into pairs, basically.
Yeah.
Yeah. Okay.
So I'm just extracting the function. I'm not using the concrete function. I'm supplying the function that I will apply to these two arguments.
Okay.
So KV1 is a function in this case. It takes an f and gives you back a list of something, which if you use the right f is going to be the same thing as line 8.
Yeah.
Okay.
Yeah. We can have the same as the first definition. We can supply the pair function.
Yeah.
Oh, you can just write the function like parentheses with the comma in it.
Yeah, it's partially applied.
Oh, that's cool.
Yeah, yeah.
Yeah, Haskell's super cool.
You know, this already what you're doing is very reminiscent of the stuff that I've been doing in K-Framework for the past like 2 days. I had like all of these freaking rewrite rules like with all concrete values, and I was like, I don't need any of this. I just need to write these auxiliary functions, and then I could do like 10 rewrite rules all at once, basically.
Yeah, it's just like a substitution or
so much nicer though. I mean, I went from like 1,000 lines of code to like 400.
Nice.
I have other functions
Oh,
oh yeah.
that I have hidden, so I must call it a different name.
So I have a quick Cabal question. When you type new REPL, this is the same as just GHCI, but it automatically loaded some of your modules here or something?
Yeah, all my models.
All the modules in your Cabal file?
Yeah.
Okay. Well, why didn't it load that one, that deep shallow one?
Oh, you mean load immediately after I start level? No, it's a load. They are available to import, so they are loaded. They are loaded in. Yeah. So my structure one is completely the same as my structure first.
Oh yeah.
Oh.
Couldn't match in with integer.
Int and integer is not, they're not the same. But
oh yeah, all right. Nice.
So now I want to make a step further and say, okay, I can replace the list. I can say,
oh, okay.
but let's first use something that we already have. So this is also valid definition. Let's better not look types immediately.
What's the dot?
It's compose.
Oh, duh. Okay.
So I want to express my my intention for this. So we don't need to create any structure. We can just say, okay, I have a function which is composed with this other function and this other function, and this is my definition.
I don't quite. I'm a little tiny bit stuck on the types of that part you just typed there. So,
but don't look the types. Don't look. Just look the structure that is written.
Okay.
Just you know, this is the characters, and we are not going to this final representation, which is much more abstract, which is completely abstract, really. Because let's look the other one. This is 2. Oops. And I could say, let's have another. This is another function that I supplied with the first argument. This is infix function. Oops.
Can you move your cursor? It's like hovering over. It looks like a pipe character or something. Oh yeah. You are writing a pipe character. All right, cool.
Yeah. This is the infix function, and I'm writing like and or, because this is written as a sequence, but how we interpret this, we can decide later.
Okay.
Because in this first definition, this is a list, and we are saying this is a sequence.
Mm-hmm.
But in this definition, we are not saying anything about how we'll interpret this structure that we have written.
Mm-hmm.
So we can also define our concrete structure.
Mm-hmm.
That would be 3. And we must supply functions for this. We can say this is. I think we can just carry the cons of the list. I think this is enough. If it's difficult to understand types when there's just supplied functions here.
Uh-huh.
But what I want, I had some. I must look at my examples here.
Yeah.
I have functions to make these types concrete. I think I can use this function. Yeah, I must supply the empty list. All right. Yeah, I can use this one when I have when I'm using compose. But if I use this kind of function, then I need. Oh, I just need to supply it compose. Yeah. So let me explain.
Yeah.
I will write the second also.
Okay, so that mystruct3 is equal to the original mystruct. No.
And the 2 is also the same.
Yeah. Okay.
All of these are now the same.
I'm not sure I understand all the syntax in the 2 and 3, but.
Oh, I don't need this here, and this one is just a parenthesis. This is the $sign. It's just application.
Oh, okay. It means apply the left function to the right function, basically. Or,
yeah. So what I'm doing here is just abstracting these two functions. First, I'm saying I will abstract only the first one that in our initial definition is a pair, and in the second example or the third, I'm abstracting also the this composition function, which doesn't have to be composition because in this example, it's really just a function. So when I supply composition, I'm really doing the partial application, and I'm getting the second one after I'm doing this.
So I totally understand how you've supplied compose in place of that and or operator, and therefore KV3 prime is exactly the same as KV2 prime. I'm not totally clear on how KV2 prime works and how you're using compose on lines 15 and 16.
I'm at exactly the same place.
So let me show the function.
So wait, does it have anything to do with this concrete thing, or is that you're defining concrete f to be to be f curry whatever?
This is t, so this is integer.
Wait, let me ask a question here. So on line 25, you have concrete f equals f, and then in parentheses curry, and then in parentheses colon. What's the colon about?
In this example.
Down on line 25. That 25. Colon is the cons operator, like to cons.
Okay. Yeah, that's right. Haskell does the single colon, whereas ML does like the double colon.
Yeah.
Switch it for the types for whatever reason.
Yeah.
Okay.
And
in concrete there, like calling curry, basically, there's not too much interesting there. That just basically says like, allow me to call cons as if it's curried, right? Like allow me to supply the list and the new head like as separate arguments.
Yeah.
And then you sort of give it like almost like the initial accumulator is the empty list, I guess, right?
Yeah. But this is not a real fold, but it's almost like a fold, because this is like an initial value, and then it's combined with the composition, and the composition is cons.
Yeah.
But the real game is that this pair and list are this pair and cons that are used here, because maybe it's better that I write exactly how this list is combined with the cons to be completely precise.
Oh yeah,
and now it's really visible that this cons is something, some function here.
Yeah.
And we're replacing this function with compose.
So what do you mean by that? Because when I hear compose, I hear apply left function to right function.
Yeah, exactly.
Okay.
So this compose. So it's like some kind of outer function that will chain these inner functions.
Yeah.
Yeah.
Okay.
So looking at line 16, on the right side of the equal sign on line 16, we have like f of a1 and then compose. So that tells me that f, whatever it is, has to be a function of three curried arguments, right?
Exactly, this one.
And
this is the three arguments.
Oh, okay.
And
yeah,
the A and the list of A's.
Yeah.
Let me see. I mean, A is a list.
Yeah, I understand. Yeah, and then, so we're taking in, like, for example, if I look at line 16 still, the arguments there, the string is A, the integer is 1, the A is whatever we got from, lines 17 and 18, and then we're given back also an A, which includes the thing we just consed onto the front.
Oh.
So then the A to the right of the parens on line 15, that's like, I'm not really sure what that one is. But then finally we're going to get back a list of string int pairs.
Yep.
So what's that second to last A on line 15?
On line 15, this one.
Yeah. Just this. Yeah. That one. Yeah.
So this will be empty list.
Oh.
Let me see.
Wait, for KV2 prime. Empty list.
We can write this. We can say KV2
with the empty list?
With this one.
Oh.
Right. This is the same. I was just playing with arguments. So this will be the F function. This one, curly list.
Yeah. Okay.
So the shape of this function will be different and depends what arguments you are using here. Okay. So there is also another way of writing this using monoid function. So I can I can say and instead accepting function, I will use monoid. So now I have and now this function depends of so that this structure that we are building must be a monoid or more concretely semigroup, which is only the append part of the monoid. Let me remove this and write this types concrete. And, so in this example, this function is does not accept this A, because this monoid already tells you that this must be like a it tells you that you cannot choose anything anything you want. You must you have some kind of constraint, and this constraint is semigroup, and the semigroup is this function. This is like a bar. You have two A's and you return A's.
Okay. Yeah.
So in that sense, we are making some kind of sequence.
Yeah.
And we can make concrete a concrete thing in the same way. With the same function, we can make this concrete type. So in the first definition, everything is concrete. Then we abstract the inner function. Then we outer function replaced with like more abstract for composition. Here we are abstracting this with the monoid, which are very similar. And in this example, we are completely abstracting, and we are saying, okay, we will supply this function, and there is there is no constraint at all.
Yeah.
I mean, the only constraint is that this function executes in the right order, because you want to first apply this and after that apply this. But this is infix function, so it will always apply after this function.
Yeah. Okay.
And now, so this is the example of final encoding, because you are not saying what is your structure immediately. You can write this definition without saying that you have a pair, that you have a list, without anything. You can just have this concrete function and turn it into a list of pairs if you want. Or what I want to show you, I have here something like a find. So I can use this function to to find some element. So B element find. So I must supply a predicate function. I'm searching for B, and my representation of my structure, which is KV4. Can I use KV4 here? Oh, I have filter by for this structure. Let me use this one. Sorry, all functions that does not work with everything. So
Yeah.
So I will filter by B, and I'm supplying this for definition. What? Oh, carry 3, not 4. All right. So. So this B element is just a, so I'm filtering only something that has B as a key. And how this works, I'm supplying this function find pair. So I'm saying I have this predicate that I will test for each key.
Okay.
And instead of generating the whole structure, the real structure, I'm using this find pair function. And I'm destructuring, I'm just using the arguments that are that this function is calling here, and I have it here, and I'm testing the key, and if key is a valid value, I will use the pair and combine the list and do the concrete thing. And if it's not the key that I'm looking for, I will just skip and return the list that I already have.
Yeah, yeah.
So if but it is visible that if I have the whole structure, I will be creating the list with all the elements, and this structure is created 2 times. First time when this is executed, and the next time when I iterating the list. But when I have some definition that is like this, I only have function definitions, and when I'm filtering, I'm iterating through this list only once. It is never created before. This KV3 this is not a list. This is just a function with a function that receives 2 functions, and that's it.
So, so that KV3 prime, that's a function you're telling me, right?
Yeah, it's.
Holy moly!
I'm not sure why Haskell is generating this type. It's not that complicated. It's complicated, but not like that. Let me show you the function.
So Tomislav, what does the double right arrow mean? I see that in 2 places now.
It's constraint.
Constraint.
So
okay.
yeah, it's a member of a type class.
Okay, so you constrain that type T before it goes into that right hand side.
Yeah, and this is a really good question because I want to explain also this thing with the type classes and what exactly they are. Mm-hmm. So this E, this means we are not saying exactly which type. We are saying this type have defined these functions. And I'm removing this and just writing the concrete types, because I want to show this like more in simple way. But this number it doesn't have to be an integer. It can be any type that implements num type class.
Yeah.
Oh, okay, that makes sense.
So I'm looking at this KV3 prime. It's a function. I call it with two parameters, and or and f. And depending on what functions I give it for and or and f, it's always going to give me back some structuring of this data, A1, B2, C3. But depending on what I give it for and or and what I give it for f, that structure might be different. Like it might be this list of pairs, or it might be a tuple of pairs, or something. It might be a list of lists if we give it the right f or something.
Yeah, and you can say I will not execute the whole thing. I will just filter by something or find the first one. For example, this find. This find function is very similar, and when it finds the one we are looking for, it will just return the pair, and that's it. Yeah. And in the other case, it returns nothing, and we can just stop executing.
Okay, so somewhere there was a line where you, I think, I don't know where it went. There, 61. Yeah, it was line 61. You've never called KV3 prime, right? That's a function. You're passing it as an argument to filter by.
Yeah. And I immediately call it.
Oh, KV3 prime is known as f. Oh, I see.
Yeah, I want to have this filter by to be function that modifies this KV function.
Oh, I see.
But you can write it in this way. You can say this KV3 in this style.
Yeah, I see what you're saying. A cool thing about the way you did it on your own, though, before I brought this up, is that in filter by, that's where you're actually calling KV3 prime, and so that's where you're actually supplying the and or and the f that goes into KV3 prime. Yeah, and so that means that filter by knows the structure, knows the sort of like deep structure that it's going to get back from KV3 prime, because it's the one that supplied compose and find pair and empty list.
Yeah, and this filter by works with the concrete type.
Yeah,
because it's saying I have something completely abstract, but I will supply these two functions, and I will work with the list and the pairs.
I see. Okay.
But you can have different filter by that doesn't work with the list. It works with the set and.
Yeah, that's what I was going to say. So if I wanted to write filter by, but my mind works just a little bit different, then I could supply something other than dot and find pair and empty list to get a different concrete data structure, and search it or filter it however my brain thought was natural. But we still get the same like sort of raw data, because the raw data comes from that function definition in KV3 prime.
Yeah, which is completely abstract.
Yeah. Oh, this is pretty cool. This is a really good demo.
And I'm not done.
Oh, but wait, there's more.
There's more.
That is the final point. Type classes. So I will copy the existing code. It will be faster. So I done it here. So maybe you will now recognize this stuff. So these are two functions. These are our two functions defined as a type class. So I'm just saying this is my language. It has two functions.
Okay.
One that accepts string and int and returns this a. And the other one is and or. It's binary, which accepts two a's and returns a's.
Yeah.
And I specified that this end or is infix left, so it will be.
The left means associative.
Yeah, the left associate. This is the percentage level.
Oh yeah.
So
oh yeah.
I just want. Without that, this will not work because this function will be applied after this one, and because they have the same percentage. So I want to have. Percentage of this to be I want the percentage of this to be more than this one.
Makes sense.
But this is like almost the same example where I'm not supplying these functions directly to these functions my x. I'm saying I have a constraint, so I can use these functions here because I have constraint on my language. Or on my final representation. This is like a more shallow encoding of this structure. I'm not saying what is this structure. I'm saying I have a language to describing this structure. So I don't have to supply the dictionary of these functions to each of my functions that I'm defining. I can just say I have a constraint.
Yeah, okay. And
this
so
is
that
completely
guarantees you that those two functions are defined on all of your A's.
Yeah, and I can use it in my function.
Yeah.
And this is how type classes are working. And this is why I was defining my final representation. I'm saying I have this constraint. I have this abstract thing. And I don't want to say in which structure I will compile it and I will reason about it. I will abstract these functions. And
so I think I mostly get the left part. So you defined those two functions on 163 and 164. But I guess I don't really see how it maps back.
Oh, so I could done something like this. This is my first function, and this is my second function.
Mm-hmm.
Right? The percentage is not correct.
Oh.
But I'm saying. Okay, I will not supply these functions in each of my functions. I will abstract. I will remove it, and I will add constraint. And this is the same thing.
That makes total sense. Okay, I'm glad we talked about that again because that's really clear now. So here's my new question. How do you know what functions you want to define? So like on 163 and 164, you chose to define those two functions. On your right side of your window, you defined those 5 Rolang looking functions.
Yeah.
Defining nil as a function is a little bit trippy to me, but basically that means like whenever you encounter a nil, you're going to give back some encoding of that thing.
Yeah. These functions are completely abstract. They are abstract like these functions, this KV3.
Yeah.
They are completely abstract. So this par doesn't tell you which two binary arguments this par accepting. It only tells you I'm setting this exactly this structure that you will use, the same one. But which structure? I'm not saying immediately.
All right. So when would someone call the nil function?
It will be called when the nil parser finds a nil keyword in the text.
Okay, and so where does it? So if you're calling it, it's got to be instantiated. Sort of. It has to at least have a definition, right? So where does it get defined then? Because I saw where you give it the type signature. That was in your type.
Yeah. So what I'm doing after this definition. So I have constraint. That's okay. So this my exp is something that depends on my lang type class. So my exp depends on these two functions.
Yeah.
Because it depends on this type class. This type class defines these two functions, and so my expression depends on these two functions. So I can make instance for this structure that I want to use. I'm making instance, and I'm providing I'm providing implementation for these two functions. I'm saying I will use a list of pairs of string int, and when you call these functions, this will be just a concatenation. When you call this function, this will be just building a list of one pair.
Yeah. Okay.
Oh.
And this is like we already somehow see this how the rolling fit in this definition, because this can be a par, and this can be, I don't know, sent. And so I will now answer your question, and I will show you initial representation. But I don't want to show you number 2. I want to show you number 3. No, semantics. In semantics, this implementation is defined. So this is implementation. So now you are saying I have this completely abstract language of functions, and when you call each of these functions, I must tell you how you will call this concrete structure.
Yeah.
So in here, it is just for each abstract representation, you are saying, okay, I will return this. I will build this structure.
Yeah, that makes sense. And the structure you're building here is the shallow encoding that made sense all along, I guess, to me at least, right?
Yeah, I mean,
or the deep encoding, I mean.
Deep is the structure. Yeah.
Yeah. Right. Yeah.
I think the initial and final is from category theory, because this is like you can now see this adjunction. You have a way to go from abstract to concrete, and you can also go from concrete to abstract.
So what's the second part of that process look like? Have we seen that, where you go from concrete to abstract?
Now, when I said this, I'm thinking.
Oh yeah, right. Right.
What does it mean to say from concrete to abstract?
Well, see, that's interesting, because I thought that was the first thing you did, was took a concrete definition and then abstracted it, and then took that abstract definition.
But I did it like manually. I'm not sure.
Okay.
Right.
It's count like a definition. I'm not sure. I didn't think about it.
Oh yeah.
But I must show you how I get this idea. So this is from Philip Wadler talk. He was saying something about this stack, and this is how it's represented in Miranda. I don't know Miranda, but I know that is very close to Haskell, and they're developed in similar time. Yeah. So he was saying that that Haskell representation with the stack that is that hides a constructor, it's like very different from this definition of in Miranda. But I rewrite his example just to use alias. So I'm not using this the concrete data like he is. So he was doing something like this. So if you have this make stack, if you don't expose this constructor to outside, no one can create this stack.
Mm-hmm.
But if we have this type alias, we can write all of these things totally the same. So I'm not sure what is the difference and what is the gain. But from his example, he was saying that he has full abstraction between his language, Lotus core, and this stack. And I remember that Greg was explaining that full abstractions is in both ways. So your question is like very interesting because I'm not sure that I know the answer.
Yeah, I didn't even realize it when I was asking it, but I'm not even sure what exactly what it means to go from something concrete like your deep encoding of a Roland program back to something more abstract.
I was thinking that when I'm doing this implementation of the instance, so I'm really saying how I want to transfer this from abstract, from shallow encoding to concrete structure. But concrete structure is the R space. This is our stack. So I'm thinking I don't want to work with any structure concretely, only if I want to do something with this structure. Because here is a part that combines these two processes in a multiset, and now you have a multiset, but you don't need multiset. You really want to have two maps that you can make a common events. So all of this structure is not needed. So in this paper, they are talking about how to extract this, and for example, make a recursion not to be part of this concrete structure, because you don't really want to have any structure until you hit the bare metal, in a sense.
Until what?
Until you hit the machine, the low-level code.
Oh, I see.
Because it's not needed. You just want to supply functions to the last moment, and in that moment just supply instance, and that's it. So I'm thinking how to abstract. So he was saying that he can abstract a stack for his language. So if we can abstract the primitives from the R space, we can directly make a transition from the final to this R space. Or we can have many different levels, but they will all combine in one execution, one function.
Yeah.
I hope this is like more clear how this final encoding fits into this.
It made it super clear for me. It's so funny because there's been multiple phases. There's been like probably 3 different times when I said to myself like, "Oh, I'm finally starting to understand this shallow encoding stuff." One of them was one of the papers you sent that I had read, but every time it happens, I was like, "Oh, I didn't really understand it as well as I thought I did, but now I understand it even better." This is one of those times.
For me, it's the same.
For me,
I was looking this talk from Phil Walderer, and I was again find something that I can write this like very simple, and I have much better understanding.
Yeah.
And now it's the problem is if you want it, because we want, we need to have this recursive definitions with the multiple types, because we have names and processes.
Yeah.
So in this paper, they are saying this is not a problem. You just define another map and sequence. So yeah, this is for me. This is a problem because you cannot use the functors that you already have. You must define all of these things again. I'm not sure how to do this. I must try.
Yeah, cool.
But if this is the way that is, maybe it's easier, I will try to investigate.
Yeah.
I see it as a abstraction mechanism. I mean, you're dynamically creating a class that's back-end independent. It is independent of the concrete type of the information. I relate to GraphQL, back-end independence.
Yeah. I'm working on one project with the GraphQL. So I don't have anything concrete now, but
yeah, well, we definitely want to get that into our stack. Maybe you should look at the portal code. It's using Vue, the Vue.js, and
I'm more for React. I don't think that Vue.js is a good thing.
you don't like it?
They have string templates, and this is like a super bad.
Well, I mean, it's puts up a really sweet browser-based application.
Yeah, you have like some useful tools, and yeah, but it's not testable because you're working with strings. Vue templates are strings, like in Angular. So in React, you have a function. Create element is a function.
I thought Vue was built on React.
Now they have a virtual DOM, and yeah, but I don't have problem with this. So I think the main thing is virtual DOM, and all the other stuff are like syntactic sugar, and they have syntactic sugar written in strings. So
right, and it seems to enable, the less capable developers to work on the user interface in a browser-based app, with the communicating with the back end.
but they have some kind of way of holding the state, which I think is more important.
Yeah.
We have more problems how to manage the state on the client than how you render it. Because if you have the state and you have your render function, you just apply it and you're done.
Yeah. Well.
The link that I shared, the coordinates with UI, in this example, he's using many different. He uses 3 different UI frameworks. I think it's called Explore React.
Yeah. Well, my situation is that the portal, which is your frame around everything you do online, your identity, browser-based, currently has a lot of functionality that's Vue. Now, in terms of adding functionality to that, it's not clear we have to use Vue. I don't know, but we need to get GraphQL interface to the portal, and that will facilitate migration to our chain of information and handle the caching.
Yeah, and if your code is, for example, just React, and you have a GraphQL API to your state, so you can use GraphQL not only for accessing server. You can use GraphQL, for example, for your local storage or in-memory storage. So you can have components that only depends on GraphQL.
Right.
And in that sense, if you have a GraphQL query and the rendering code, you just apply it and you get the state. And Apollo, I think it's it has some kind of nice features. If you want to have all these things like already built.
Yeah, well, we built the GraphQL interface to the bounty system, and we use GraphQL access to GitHub. So I'm familiar with it, but you know, the development of it is kind of stalled because nobody's engaged in it right now. If you could help guide that development, that would be awesome. Because you know, the social ledger well,
so you have a backend, yeah. So you want to have a GraphQL API at the front, and now you first want to have a GraphQL backend in some database.
Yeah, GraphQL to service your wallet and your browser-based information, as well as GitHub and your secure chat and the tools you use that are part of the social ledger of your interaction online.
So where are you now storing GraphQL schema and the data?
Well, I mean, besides the it's in MySQL in the bounty system. So we use SQLize for that. And,
okay, and how schema is defined? Classically, with in a file, right?
Yeah, well, you've got the two files you create for.
It is manually written.
Well, SQLize does some of the work. Yeah, it's manually done.
Yeah, but between SQLize and GraphQL, you must have some kind of bridge that you can say. I'm asking. Do you generate the schema from the SQL, or are you using some kind of framework?
I actually don't know the exactly what work was involved.
Where is the project?
It's GraphQL.robot.net.
But your project?
It's a Colab. I'm trying to remember. IBE has done most of the work on it.
It's on our Archain community GitHub, right? Or
no, I guess not. I would just presume that it's got to be on Jim's server, but I think IDE had.
Can you send a link to the chat?
Sure, it's pinned in the GraphQL channel, Colab.
Okay.
And you can see the schema and everything if you just go to the site. Okay, you can browse the tree and write queries, whatever. Maybe not. I wonder if MySQL is running. Oh well. So much for that demo. But yeah, you can. You know how to use the what do they call it? The graph. The interface.
You're saying on your GitHub is this?
Yeah, I don't. That's
okay.
Look at Colab, GraphQL, pinned items.
Is this the one?
Yeah, this is the one. I'll put it.
Okay, okay. Yeah, I find it. Okay. Okay, schema definition is in GraphQL syntax with types defined. Yeah.
Okay.
So what I was thinking from GraphQL and the Archain. So let me share the screen.
Tomislav, I didn't know you had done work or put thought into GraphQL, or especially with respect to Archain.
Oh yeah, I was thinking about GraphQL and yeah.
Did you know that, Jim? I've known Jim was into GraphQL for months now.
Yeah, I was talking to Jim in Berlin, but yeah.
Oh, cool.
What I have problem with the GraphQL, you define types like this, and like GraphQL is really great, but there is again you have a static definition. So what I was thinking for Archain, we can have a dynamic definition for our schema.
No, why can't you generate these dynamically?
From the code.
Right.
So now we have. Yeah, now we have Archain as a database, so we can generate these types, because you have GraphQL has API for this, so you don't have to generate exactly this syntax, but you can generate the abstract syntax for this type definition, and we can generate this from rolling code, and we can say this is something that you already done, Jim, for object storage, or you call it node, or something like, yeah, like they're like objects. So we can define like a graph that defines our schema, and we can for this schema generate a query.
It's exactly
And the
what
graph,
we're doing. And then our interface is going to be in Vue.js.
yeah, or we can make a different interfaces. We can generate the API for each language, and yeah.
Right. Yeah. Well, the portal is only a frame around for you, whatever you put inside of it.
Yeah. I'm interested in this. So yeah.
Awesome. Great. We have to. When can you attend?
Yeah, I'm just thinking, but I don't want to promise anything.
When can you participate in one of the 2 p.m. New York time work studies on Monday, Tuesday, and Thursday?
Oh, now it's very difficult to attend this, but
Well, maybe you can attend once a week or once a month.
yeah, I will try.
Yeah, it would be good if we could plan it.
I will definitely look at a repository.
That's not the repository for the portal. You have to go to the social ledger channel for that.
So okay, please send me these links so I can see.
Oh my! There it is.
Hey gang, I'm gonna jump out soon. Tomislav, thank you very much for that tour through the deep and shallow encodings. It makes more sense every time.
Cool.
That's up on your repo, right?
No, this
but
isn't.
It can be or will be.
Yeah, I will put this in.
Cool.
I will clean it up and I will put this.
Awesome. Good hanging, guys.
If you have any questions, please ask.
Okay. Yeah. That sounds awesome.
Cool.
See you guys later.
Bye.
Yeah, I'm gonna jump off too, guys. Thanks a lot, Tomislav, Jim, Gary.
Bye, Isaac.
See you guys.
See you. So, Big Life Portal, Git, remote, -v. Oh, not Git, got Git.
Oh yeah.
So it looks like it's just on Joachim's. There's Joachim's, I guess, is the master at this point. It should be moved to probably it'll go on the Digital Life Collective. Portal, but I should probably give you and this should be available. So
yeah, I found it. Yeah, I found it. Are you using Firebase? Or you said MySQL, but here's some code for Firebase.
The portal's currently using Firebase.
Okay. Did you find the Prisma framework?
Is that the I know there's a tool for a GraphQL Firebase tool.
This Prisma is, I think that currently they have a support for MySQL and Postgres, and you can define your schema, and it will automatically reflect on your database, so you don't have to do this manually.
Definitely looking at that as.
But they didn't implement everything. For example, you cannot order by two arguments, by two parameters. So they have some limitations, and I'm not sure if this is ready for production. But yeah, I wanted to say related to GraphQL, what I was thinking for GraphQL is like a R-Node API via GraphQL. This is initially what I was talking to also to this guy from Hong Kong, Anson. But I I didn't start on this, but yeah, I have it in my mind.
Yeah.
So we can really have only one interface, GraphQL interface to all the services. You can access to Node, and you can like search for schema and everything.
We can stitch schemas, right? So what I don't know what you mean by one. Everybody has their own schema in their browser or their personal, their wallets and such.
Oh yeah, you can have your own database, right? With your own schema. That's the point. Yeah, yeah,
right.
yeah.
And you're connected. You can query across all of your data sources.
Yeah, yeah, and I'm thinking that in that sense you can connect to multiple nodes. For example, you have public and private repositories on GitHub. So maybe you want to have like a private database that you run in your home, and then you have like a different node, and maybe you want to exchange the data. Because you can work on something on your local node, and then you publish on the public node. And
interesting. I mean,
this is why I'm thinking that we need to store the contracts, the raw and code in our node. But I'm not sure that we can have comments. So when you write comments in Roland, they're not important. You can execution doesn't depend on the comments, but if you want to store the code as a data, what about comments? The comments must be written somewhere. We don't want to store contracts as a string. We want to store it as a real code because we have full reflection. But what to do with the comments, I'm not sure. Can we write it as a string, then convert it to comments? I'm not sure. But why to store rolling code somewhere else when we have a node?
Well, the thing is that everything is going to need to be cached, and this is where Postgres backend can support scalably a cache.
Oh, you mean before we can use R node for a cache?
Right.
Yeah. Yeah, that's why I'm thinking that maybe it's possible to write for this kind of things very lightweight node, which is not constrained for a blockchain. So you can just run it as a cache on your machine, and you have all these nice things.
Right, and we have a community cache.
Yeah, yeah.
Okay, so the Colab cache.
Yeah. And this is exactly how I'm thinking on this transformation from a code to execution.
Right. I'm struck by sort of a correspondence in GraphQL to Rolang, and I'm wondering, what's the minimum extension to GraphQL, to support, PAR.
Yeah.
Or, it already has a subscribe.
Yeah, now it's have subscribers in the definition. Yeah.
So it can do a read.
What is missing is they don't specify anything about aggregation. This is just a simple API without any with only minimal query language. So yeah, but I think we can add. So when I'm thinking in GraphQL in more advanced way, I'm not sure that the syntax is good enough. I'm thinking that
that's what I'm saying here. We can't actually program in it.
yeah, and Greg is saying that Rolling is the best query language. So I'm thinking, how can we gradually push something, some Rolling capabilities inside the GraphQL? Because in Rolling we are doing query in a way like a prolog is working. So maybe we can have these kind of constructs also with the model operators, and this will be interesting.
Yeah. Well, I'm also planning on running Rolang in the browser written in Rust.
Oh, cool. In Rust, but executing with the WebAssembly, right?
Yes.
So soon everything will run with WebAssembly. So.
Yeah.
Okay. Should we finish for today?
Yeah. I don't know if I'll live to see it, but it's good.
Yeah, I will try to attend, but yeah, yeah.
Later, guy, and check your schedules on Monday, Tuesday, and Thursday for the 2:00 New York time call, and see if we can get some engagement in moving forward on the GraphQL work with the portal.
I will definitely look at the repository, so I will try to make some.
Yeah, you can.
Okay.
Asset the damage. Bye bye.
See you. Bye bye.